We are studying chapter number 5 in Maths 2, which is coordinate geometry. We will continue with that and we will focus on the next and the last concept for this year, which is called slope of line. Slope of line. This is what the three main points that the chapter contains. One is the distance formula. Second one is the section formula. And the third one is the slope of line. If you remember, we have already covered the distance formula. We have seen how it is derived, what it is, what are its applications, and we solved questions of practice set 5.1. Then in section formula, we understood what it is, how it is derived, and how it can be used for midpoint and centroid also. And we solved the questions in practice set 5.2. Today, we will learn about slope of line. Before we start that, quick revision. We must ensure that when we are moving forward, we don't forget what we have studied earlier. Distance formula in a very simple way, in a very general way, is denoted like this. If we have 2 points P and Q with coordinates x1, y1 and x2, y2, then the distance between them, and very important here is that they are on the plane, they are on one plane. At this point in time, we are only talking about one plane. When you study more and more, when you go to higher classes, then you will understand how the formula will change if the points are not on the same plane. We are not going there now. At this point in time, whichever points we consider, they are on the same plane. So we can calculate the distance between P and Q as square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula. As I told you, we need to know, we don't need to know how this formula came about, but we should know how the formula came about. If we know it, then it will be easy for us to understand other questions and use the formula in various other places. So quick warm up. If I tell you that the 2 points are, suppose, -1 and 2 and -2, -2. Quickly calculate the distance between them, whatever may be the names of these points. Maybe first point is A, second point is B. A is -1, 2, B is -2, -2. Find the distance between them. So Chandra, your answer was correct. The distance between these 2 points, A -1, 2 and B -2, -2 comes out to be square root of 17. In section formula, we studied that if you have a line segment joining 2 points x1 and x1 y1 and x2 y2, and if there is another point on this line segment which divides this line segment in the ratio m:1, then the coordinates of this point which divides this line segment in the ratio m:1 can be found out by the formula. For x, we have mx2 plus nx1 by m plus n, and for y, my2 plus ny1 divided by m plus n. Now, suppose I tell you that we have the same 2 points. What are the 2 points? I don't even remember now. I think it was -1, 2 and -2, -2. These are the 2 points. And there is a point which divides the line segment joining these 2 points in the ratio 2:1. Then find out the coordinates of the point which is dividing this line segment. What is x coordinate and what is y coordinate? Using the section formula directly, in this question, we all know everything. We know x2, y2, we know x1, y1. We also know m and n. So to find the x coordinate of the y that is dividing the line segment, we will use this part, mx2 plus nx1. M is 2, x2 is -2, plus n is 1, x1 is -1. by m plus n. This is 2 plus 3. So 2 into minus 2 is minus 4. 1 into minus 1 is minus 1. 2 plus 3 is 5. So we have 2 plus 3, not 2 plus 3. It should be 2 plus, I'm very sorry. It should have been 2 plus 1. 2 plus 1 equals to 3. So we have minus 5 by 3. Chanda and Prachi, correct answers. Chan, correct answer. When we do the same thing for y, now we will use this formula m by 2 plus n by 1 divided by m plus n. So same 2 and y2 is minus 2 plus 1. Now y1 is 2 divided by m plus n. So 2 plus 1. 2 into minus 2 is minus 4. 1 into 2 is 2 divided by 3. Minus 4 plus 2 is minus 2 by 3. So the coordinates are minus 5 by 3 and minus 2 by 3. After that quick revision, this is what we will study. This is what we will learn. This is what we will practice in the current session. We will focus on slope of line. Okay? It's the last part of the chapter. It's an easy part, but it has some trigonometry also. It has a lot of algebra. The concept is very simple. I don't think you will have any problem understanding the concept, but using the concept, so from knowledge to understanding to application, things will only become difficult if we don't understand algebra and if we don't understand trigonometry. So what we will do about slope of line is we will look at the general case, we will look at special cases, we will see how the slope of the line can also be expressed in terms of angles, and finally we will see what are the applications of the concept of slope of line. Not all the applications, but just 2 applications we will see. So this part of the chapter starts on page number 116. Page number 116 of your textbook. Slope of line. What is the slope of line? Let us first understand the physical concept of slope, and then we can try understand the mathematical measurement of the slope. In your textbook, in our textbook, 2 words are given. Where this section, slope of line, starts, 2 very important words are given. One word is plane, says someone is walking on the plane. The man here, or the boy or the girl here in the picture on the left hand side. It said that that person is walking on a plane. But the man, the boy, the girl who is walking on the right hand side of the picture, it is said that he, she is walking on a slope. Now you know what a slope means. Plane is something that is horizontal. Slope is something that is inclined, more appropriate words. And then there is something in between, which is called vertical, not in between. There is another concept which is vertical. If we draw these things, then how will they look? Let us see how the horizontal, the vertical, and the inclined look. A horizontal would be like this. A vertical would be like this. ये हम सबको पता है. Either it is completely plain, either it is, or it is completely standing up. Now there can be some things in between. For example, what is happening here? What is happening here? Or what is happening here? Now these lines are neither horizontal nor vertical. Okay. So slope relates to slope relates to something, some relationship between height and distance. It has got something to do with height and distance. Let us once again try understand what it is. In English, it's very easy. In English, it's very easy. Something which is inclined. या तो ऊपर जा रहा होगा या नीचे आ रहा होगा. That is slope. But if we try to understand it mathematically, this is very important. Pay attention. The meaning of slope is how one slope is different from another slope is how much vertical. That is the interesting part. Is the line like this? 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 Or is the line like this? Or is the line like this? Is the line like this? Line like this. And what is happening in these cases, if we once again look at them in a little bit more detail, when we are walking, when anyone is walking, so we are walking on the plane, or suppose we are walking in one direction, we are also walking in this direction. That is what is happening when we are walking on a plane. Let me show. Right. So we are covering some distance in the x direction. We are also covering some distance in the y direction. Now, if you try to compare this line in the red with, say, another line. Let me draw it in another color. Let me draw it in green. It did not come in green. Clearly, whether it is red line or the green line, if we move from, say, A on the left hand side and B on the right hand side, I will show what A and B are. This point is A, this point is B. When someone is moving from A to B on the red line or on the green line, the horizontal distance that is covered, it remains the same. But the vertical distance that is covered is more in case of the red line than in case of the green line. And that is the concept of slope. We already know that if we keep a ball on the red line and if we keep a ball on the green line, we know that the ball on the red line will move faster. It has a higher slope, greater slope. Why has that happened? Because the amount of vertical distance is more for the given horizontal distance. That is the concept of slope. How much is the vertical distance with respect to a particular horizontal distance? If we study this slope in a little bit more detail, and of course the first case will be the general case, I've taken the example from the textbook, is this. So the textbook has not explained to you what exactly is the concept of slope, but the textbook takes an example of a line in a plane. Someone please come out of mute and tell me what line is there. What is the name of this line on the screen? Are you able to see the line? Line, not the axis. What is the name of this line? The name of the line is L. Thank you. In the chat and on the mic also. Correct. Name of the line is L. And there are 5 points shown on that line. What are the names of those 5 points? They are A, B, C, D, and E. And this line is imagined. Thank you. This line is imagined on the XY plane. XY plane is the plane that has the x-axis and the y-axis perpendicular to each other, the coordinate plane. And because we have the coordinate plane, we can find the coordinates of these 5 points. And it is already given 6, 7, 4, 4, 2, 1, 0, -2, -2, comma -5. We already know this. There is no mystery about this. Now, if we try to find out a ratio for some pairs of points, what pairs of points? These pairs of points, C, E, A, D, D, A. The ratio that we are trying to find out for each case is y2 minus y1 by x2 minus x1. Now, what is x1, y1? What is y2, x2, y2? The first point, the point on the left will be, we will consider as the first point. The point on the right will be, we will consider as the next point. So in first case, CE, C is considered x1, y1, and the coordinates of E are x2, y2. Using that, when we calculate this ratio y2 minus y1 by x2 minus x1, we are getting 3/2. We are getting the same thing for A and D also. We are getting the same thing from D and A also. That means even if we change the direction, even if we change the order of the points, the ratio remains same. Quickly look at these calculations and confirm if they are correct. If you think the calculations are wrong, tell me, we will correct them. If we take the example of B and C, I'm looking at the textbook about to find the coordinates of B and C. You should also be trying to doing this in your notebooks. If you are doing this in your textbook, then you should be using your pencil. Okay. So coordinates of B are 0, -2. Coordinates of C are 2 and 1. Let us complete this and see what we get. So y2 minus y1 will be 1 minus -2. And x2 minus x1 will be 2 minus 0. Now 1 minus -2, 1 plus 2 is 3. 2 minus 0 is 2. Again the same ratio, 3/2, 3:2. Check what you are getting for C and A. Help me write it. What are the coordinates of C? What are the coordinates of A? What is the ratio? y2 minus y1 and x divided by x2 minus x1 in case of CA and in case of AC. Calculate and confirm. And the set is we will get, very sorry about this, 3/2 here. Also using the same coordinates, for A it is -2, -5. For C they are 2, 1. When we put them in the formula, we will get 3/2. So what we are seeing here is, we have a line. If you remember, the name of the line is L, and there were 5 points on it, A, B, C, D, E. And if you take any part of the line, if we take any 2 points on the line and we calculate this ratio y2 minus y1 divided by x2 minus x1, it is coming to be same. And this ratio is called the slope of the line. This ratio is called the slope of the line. Now this is very, I don't know how you will feel if I tell you this is called slope, if I don't tell you why it is called slope. But we are observing that this is same. Why it is same, I have already explained to you. I said, we understood that slope has got to do with vertical distance per unit horizontal distance. Now, see if that is exactly what we are doing here or not. When we take 2 points x1, y1 and x2, y2, the vertical distance between them is y2 minus y1, of course. The horizontal distance between them is x2 minus x1, of course. So the way we defined slope, हमने slope क्या कहा था कि कितना vertical distance है, it is y2 minus y1. कितने horizontal distance पे इतना vertical distance है, it is x2 minus x1. So this ratio is called the slope, mathematically speaking. And this ratio is usually denoted by alphabet, which is small m. When we say m equals to 3 for a line, or m equals to 1 for a line, or m equals to minus 1 for a line, what we mean is the slope of the line is minus 1. What we mean is if we take any 2 points on the line and calculate y2 minus y1 divided by x2 minus x1, we will get that value m. Now let us look at some special cases. General case was just any random line L was there and we took 5 points on it. Now we will take some special lines. Special cases means special lines, because here we are trying to find the slope of line. Of course, lines that are horizontal, lines that are vertical, those are the special cases. Also, the axis themselves, the x-axis and the y-axis. Now we know that the slope of a line is given by the formula m equals to y2 minus y1 by x2 minus x1. Keeping this in mind, let us look at these 4 special lines. First one is the x-axis. It's there on the diagram. It's there on the screen. If you remember, all the points on the x-axis, they have their y-coordinate as 0. So y2 will also be 0, y1 will also be 0. And let the x-coordinates be x2 minus x1. Now we know 0 minus 0 is 0 by something. Now we have to use something that we studied in basic division. 0 divided by anything is 0. 0 divided by anything is 0. That means the slope of x-axis is 0. है ना? तुम देखो वो पूरा सोया हुआ है. X-axis is sleeping. Horizontal. No slope at all. No slope. No slope means slope is equal to 0, mathematically speaking. What happens to lines that are parallel to x-axis? Suppose the line M here. This is not the slope M, this is the line M. Now if we take any point on this line, now the y will remain constant. It will not be 0, it will be constant. Here also y, here also y, here also y, here also y, and it is this y. So for the line parallel to x-axis, the slope will be y minus y by x2 minus x1, which will be 0 by x2 minus x1, which is once again 0. So whether it is the x-axis or we have a line which is parallel to x-axis, all of them will have 0 slope. The slope of all these lines, the x-axis and all the lines parallel to x-axis, is 0. Completely opposite thing happens on the y-axis. On the y-axis, the y-coordinates are there, but the x-coordinates are 0. Now this becomes y2 minus y1 by 0. Now once again, if we know our division properly, we know that we don't know how to divide by 0. Not determined, not defined. So the slope of the y-axis cannot be decided, cannot be determined, cannot be calculated. Similarly, if we take a line which is parallel to y-axis, in this case the line L. So now in this case, so we have the y coordinates, y2 minus y1. Now the x coordinates are not 0, but they are same. So it will be y2 minus y1 by 0. And once again, cannot be determined. Let us now try to understand more general cases and more understand what are the possible values of a slope of a line. What can be the possible values of slope of line? Now we know how to calculate the slope of a line. Y2 minus y1 by x2 minus x1. How many lines do you see on the screen? What are the names? Don't tell me about the axes. Tell me about the lines. What are the lines? How many are there? Very good. T, L, and N. You see 3 lines, T, L, and N. Let us try find their slopes and see what we observe. And we will go in the alphabetical order. So we will start with the line L. We will start with the line L. Slope of line L. Remember, the order of the points don't matter. We have already seen that when we were understanding the mathematical basis of slope. So when we consider the line L, the points that we can consider are A and B. So we can take A as x 0.1. We can also take B as 0.1. Because the coordinates of B are bigger, let us take coordinates of B as second coordinates. So we will write 1 minus 0, that is y2 minus y1 by 6 minus 4, x2 minus x1. So we get 1 by 2. Slope of L is 1 by 2. Now you tell me what, using same logic, using similar formula, how can we find the slope of the line N, not T, N? We are going in alphabetical order. You tell me, I'll write. How do we find the slope of line N? Yes, Chanda, please speak.
1 minus 3.
1 minus 3? No, we can't do that. Why will we do 1 minus 3? Akhilesh, Rajesh, you want to try? Try.
1 minus 4.
Correct.
6 minus 3.
6 minus 3 is correct. Thank you, Akhilesh. Now 1 minus 4, Chanda, don't confuse between x's and y's. So 1 minus 4 is minus 3. And 6 minus 4 is 2. So slope of line N is minus 3 by 2. Let us try another line, which is the line T. Who will tell me now? Yes, Chanda, go ahead.
Uh, 3 minus minus 1.
3 minus minus 1, no. Once again, wrong, Chanda, sorry. Yes, Akhilesh.
4 minus 0.
4 minus 0.
3 minus minus 1.
Correct. 3 minus minus 1. In the numerator, we have y2 minus y1, Chanda, not x2 minus x1. Be careful. So 4 minus 0 is 4. 3 minus minus 1 is 3 plus 1, 4. And we can say it is 1. Okay. So very clearly, what we see is, what we saw in the earlier screen is, the slope can be 0. The lines that are horizontal. Now we are seeing that the slope can be positive, that the slope can be 1, the slope can also be negative. हाँ कि ना? Slope can be 0, slope can be positive, slope can be negative, slope can be 1 also. If we try to generalize this and understand what is happening, let us draw another coordinate system. We have the y-axis, and let us draw the x-axis also. X-axis. Now, the slope of the horizontal line here, I'm very sorry. Slope of the horizontal line is 0. The slope of this line beta, this is 1. The slope of line which is here, it is from something between 0 and 1. Something between 0 and 1. From here to here, it is more than 1. But all these lines have a positive slope, 0 or a positive slope. The moment line becomes like this, the slope becomes negative. Means अगर वो line यहाँ से भी आया होगा थोड़ा सा भी, it will become negative. Why that happens? It's very, very simple. The way we have defined the coordinate system. We have the quadrants. We have positive side of the axis. We have the negative side of the axis. Because of that, slope can be 0. Slope can be 1. Slope can be positive. Slope can be negative. Also, the slope changes with what the incline, what is the incline of the line. Very commonsensical. No rocket science here. If we try to summarize our observation about the values of the slope, we can say that slope can be positive or negative. It is positive when the line makes an acute angle. Kaisa? This line, this angle is acute. It is less than 90 degrees. The slope of the line is negative if the line makes a obtuse angle with this angle. So the angle that the line makes, with the positive side of the x-axis is the angle that tells us whether the slope will be positive or negative. If the angle is an acute angle, it will be positive slope. If the angle is an obtuse angle, then it will be negative slope. In addition, if the angle is smaller, the slope will be smaller, lesser. If the angle is larger, then the slope will be bigger. है ना? इस वाले लाइन का स्लोप कम है, इस वाले लाइन का स्लोप ज्यादा है. So we have understood the concept of slope. We have learned the mathematical description, mathematical calculation of the slope of a given line. Let us try find out the slope of this line. Example number 1 on page number 120. Page number 120. Very, 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 very simple question. Very straightforward question. It says, find the slope of a line passing through points A -3, 5 and B 4, -1. We know by now that the slope of the line is given by m equals to y2 minus y1 by x2 minus x1. So where are our x1, y2, x2, y1? So x1, y1, x2, y2. So if we calculate the slope, it will be y2 is minus 1, y1 is 5. So y2 minus y1 becomes minus 4 comma minus 5. Then if we look at x2 minus x1, x2 is 4, x1 is minus 3. When we solve this, minus 4 minus 5 is minus 9. 4 plus 3 is 7. Minus 9 by 7. मैंने सही किया, मैंने गलत किया, क्या हुआ चेक करके बताओ. Very good. What I wrote wrong here is
Y1.
correct. Y1 is minus, not Y1 beta. I wrote
Y2 minus
Y2
1.
wrong. Yes, Y2 I have written wrong. I should have written minus 1 instead of I wrote minus 4. Thank you. So when we correct it, minus 6 by 7. This is the slope. Question number 2 of practice set 5.3. Boys, you are trying to solve part 1. Girls, you are trying to solve part 2. Very simple. Lines passing through 2 points. So the 2 points in each case are given. So we have x1, y1, x2, y2. All we have to do is find the slopes. In your notebooks, then share the answer in the chat. So the question that girls were trying to solve, so our slope m will be y2 minus y1, so minus 2 minus 1 divided by x2 minus x1, so 5 minus minus 3. So minus 1 minus 2 minus 1 is minus 3, 5 plus 3 is 8, minus 3 by 8. The question that the boys were supposed to answer, slope of the line m is again y2 minus y1, 7 minus 3 by x2 minus x1, 4 minus 2, 7 minus 3 is 4, 4 minus 2 is 2, 4 divided by 2 is 2. So girls should have given the answer minus 3 by 8 and boys should have given the answer 2. So the line of the boys would look like this. The line of the girls would look like this, because the slope that boys are getting is positive and the slope that girls are getting is negative. Also, I have drawn the line for the boys the way I have drawn because the slope is more than 1. So the line will be, the upper part of the line will be nearer to the y-axis, not exactly between x and y. Let us now see if there is another way of expressing, of calculating the same slope mathematically. Right now we have looked at a ratio y2 minus y1 by x2 minus x1. And we are constantly saying that it depends on the line aisa hai, aisa hai, aisa hai, aisa hai, aisa hai. So we are dealing with angles. We are saying smaller angle, smaller slope, bigger angle, bigger slope. So how do we express the slope of a line with respect to angle? There we will use trigonometry. We will use trigonometry. It's very simple, very, very, very simple. So once again, we have a line L. It is on the xy plane. So the x-axis and the y-axis are clearly shown in the diagram. The line L passes through 2 points P and Q. Coordinates of P are x1, y1 and coordinates of Q are x2, y2. Now, by the definition that we have learned, mathematical definition, m equals to y2 minus y1 by x2 minus x1. This we have learned. But if we imagine, if we simplify this line, if we draw perpendiculars from the points P and Q onto the axis, then we get a right angle triangle P, Q, R. Now here, y2 minus y1 is QR. and x2 minus x1 is PR. When we say m equals to y2 minus y1 by x2 minus x1, what we are essentially saying is it is QR by PR. Now in this right angle triangle, if the angle made by the line on the positive direction of x-axis is theta, then this is also theta, corresponding angles. Now QR is the opposite side and PR is the adjacent side. So the ratio that we are getting now is opposite side by adjacent side. And we know that this is nothing but the tan function. So we can also say that the slope of the line is tan theta, where theta is the angle made by the line in the positive direction of the x-axis. Simple. We understood m equals to y2 minus y1 by x2 minus x1, and we looked at the special cases. Now we have understood that m is also equal to tan theta. So we will again once again look at the special cases. And of course, the special cases are the same cases. Same, exactly the same. X-axis, line parallel to x-axis, y-axis, line parallel to y-axis. Now you help me now. You help me. You tell me for x-axis, what is theta? What is the angle x-axis is making with the positive direction of x-axis? If you put a protractor on x-axis and measure the angle that it makes with itself, what angle will you get? No, Khadija. Positive direction of the x-axis. That is, I thought some of you will give this answer. That is why I asked this question. What is the angle will you get? This is the x-axis, huh? And there is a line. Huh? So what is the angle that the line is making with the positive direction of the x-axis, not the negative direction? Chand is saying acute. I'm not asking about the nature of the angle, beta. I'm asking you the measure of the angle. Chanda is saying 90 degree. Really, beta? If we draw a line on the x-axis, you are telling me it is making an angle of 90 degree with the x-axis. How is it even possible? Let us try, see, draw. This line I have drawn. This is making an angle of 90 degree with the positive direction of the x-axis. ये हमारा x एक्सिस है, उसके ऊपर लाइन यहीं पर है. एंगल कितना है? कार्तिक, करेक्ट बेटा. The angle that we get is a 0 degree angle. 0 degree angle. So the slope of x-axis will be tan 0. Tan 0 is 0. Similarly, all the lines that are parallel to x-axis, they also make 0 degree angle with the positive direction of the x-axis. So tan 0 equals to 0. यही तो हमने बोला था ना, slope of x-axis and all the lines that are parallel to x-axis, slope is 0. See, slope is 0. Similarly, the angle made by y-axis with the positive direction of x-axis, this is 90 degree. So the slope will be tan 90. Tan 90 we cannot know. Check karo. Similarly, all the lines that are vertical, all the lines that are parallel to y-axis, we cannot find the slope because theta equals to 90. So whether we use the coordinates of points on the line or we use the angle that the line makes with the positive direction of the x-axis, we can find the slope. y2 minus y1 by x2 minus x1 or tan theta. Look at question number 1 of practice set 5.3. That angle theta, the angle that a line that is line is making with the positive direction of x-axis is given. Using this angle, we have to find the slope, and we know the formula. The formula is m equals to tan theta. M equals to tan theta. So quickly tell me, what will be tan 45, what will be tan 60, and what will be tan 90? You can refer to your textbook. You can go to the chapter trigonometry and find the correct answers. So we have understood the concept of slope. We have understood how slope can be calculated in two different mathematical ways, using coordinates and using the angle that the line makes with the positive direction of the x-axis. We have seen all the different possible values of the slope. Horizontal lines, slope is 0. Vertical lines, slope is cannot be determined. Positive slope, negative slope, all we have seen. Using these knowledge, we can do certain other things. We will look at just two concepts, two applications. First one is collinearity. Chapter 9, not chapter 9, class 9, maths 2, chapter number 1. Collinear points are points that are on the same line. And you already know that a line, whichever portion we take of a particular line, the slope remains same. That is where we started. We looked at line L. We took 5 points on it: A, B, C, D, E, and whichever part we took, A, B, or AC, or DE, or whatever, the slope was 3/2 or 1/2, whatever it was in that exercise. 3/2. That means if we have 3 points, if we have points that are collinear, that means they are on the same line. That means उनके बीच का जो slope है वो same होगा. क्या मतलब है उसका? एक बार फिर से देखते हैं. Suppose P, Q, and R are like this. Collinear, that means they are on the same line. Same line means the slope of PQ will be equal to slope of QR will be equal to slope of PR. यही तो है. So if we have to show, अगर हमको बताना पड़े that P, Q, R are collinear, all we have to do is find the slope of PQ, find the slope of QR, and see if they are same or not. If they are same, they are collinear. If they are not same, they are not collinear. Let us see what is happening in this case. You know how to find the slope. I will find one part, you will find another part. So if you are finding for PQ, slope can be found out as y2 minus y1, so 2 minus 3, x2 minus x1, so 1 minus minus 2, 2 minus 3 is minus 1, 1 plus 2 is 3. The slope I am getting is minus 1/3. You tell me the slope for QR. How can we find? You tell me, I will write. Slope of QR. Oh, someone has calculated. Okay. Yes, Chanda. Tell me the each and every part. Chanda, speak now.
1 minus 2.
Nope. So once again, let me see. Maybe I saw it wrong. Wait. Something I'm not able to. Yes, Chanda, you were right. Please complete.
1 minus 2 upon 4 minus 1.
Correct. 1 minus 2 by 4 minus 1. 1 minus 2 is minus 1. 4 minus 1 is 3. So what we see is slope of PQ is minus 1 by 3. Slope of QR is also equal to minus 1 by 3. That means they are collinear. That's all. Question number 3 of practice set 5.3. Question number 3 of practice set 5.3. Now this time, girls, you are doing part 1 and boys, you are trying to solve part 2. Girls, part 1, boys, part 2. 3 points are given. We have to find whether they are collinear or not. What we have to do is we have to find the slope of 2 parts, AB and BC for 3-1 and DE and EF for 3-2. So the question that girls were solving, question number 1 on the left hand side, if you try to find the slope of AB, our M will be 1 minus minus 1 by 0 minus minus 1. 1 minus minus 1 is 1 plus 1, which is 2. 0 minus minus 1 is 0 plus 1 is 1. The slope is 2. Let us see the slope of DC. Now 3 and 1. 3 minus 1 and 1 and 0. 1 minus 0. 3 minus 1 is 2. 1 minus 0 is 1. 2. Correct. Collinear. Girls have given the right answer. Let us see what the boys have done. So for DE, our M will be 0 minus minus 3. It can also be minus 3, 0, but you have to stick to one way of doing. 1 minus minus 2. 0 minus minus 3 is 0 plus 3, which is 3. And 1 minus minus 2 is 1 plus 2, which is 3. Is 1. Then EF. So M equals to 1 minus 0 by 2 minus 1. 1 minus 0 is 1. 2 minus 1 is 1. So yes, DEF are also collinear because they have the same slope, 1. Both have the same slope. The next application of slope of a line is to understand or to identify parallel lines. And for this, we have to go to class 9 once again, corresponding angles. Now, if we have 2 lines L and T such that they make the same angle theta with x-axis. So this x-axis now, x complement, is acting as a transversal. L and T are 2 lines which are intersected by the transversal x-axis. And the angles which are theta, they are the corresponding angles. So we can say that L is parallel to T. Line L is parallel to T. Why? Corresponding angles test. Same theta. Right? Now, if the theta is same, the tan theta will also be same. And tan theta means slope. That means parallel lines have the same slope. अरे इसमें नया क्या है? ये तो हम सबको मालूम है. हाँ, सबको मालूम है. But we get confused. We will see these lines and we will think that the slope of line L is more than the slope of line T. Why? क्योंकि हमारे दिमाग में ये चलता है line L जो है T के ऊपर है, उसका slope ज्यादा है ना. Slope is not about what is above and what is below. Slope is about what is the angle the line is making with the x-axis. So if the lines are parallel, their slopes will be same. And the converse, if the slopes are same, that means the lines are parallel. And it is not just with respect to theta and tan theta. It is also with respect to the coordinates of the points on the line. Let us check for L. On the line L, we have the points A and B. And if you try to find the slope of L, we can do 3 minus 0 by 0 minus minus 3. Y2 minus y1 by x2 minus x1. So 3 minus 0 is 3. 0 plus 3 is 3. Slope is 1. Now let's try to do the same thing for the line T. Then you will say, sir, where are the points? Yes, there are points. This point is 2, 0. This point is 0, minus 2. So if we apply the coordinate swallow formula for slope, 0, 0 minus minus 2 and 2 minus 0, which is 2 by 2 equals to 1. So the slope has to be same if the lines are parallel. If the lines are parallel, slope is same. If the slope is same, lines will be parallel. Doesn't matter how we are calculating the slope, whether we calculate it through the angle tan theta or we calculate using coordinates. Once we have understood how to identify parallel lines by checking their slope, whether we check the angle or we check the coordinates, we can use it to find out if a quadrilateral is a parallelogram or not. A similar question was there previously also. It was there when we learned the distance formula. I will show you where it is on page number page number 105, example number 4. It says show the points 1, 7, 4, 2, minus 1, minus 4, 4 are vertices of a square. Parallelogram. And that we did by using the distance formula B, because remember, there are multiple tests of parallelogram. There are tests with respect to the length of the sides. There are tests with respect to the parallelity of the sides. We know a parallelogram is a quadrilateral where both the pairs of opposite sides are parallel to each other. Example number 4 on page number 121. That 4 points are 6, 1, 8, 2, 9, 4, and 7, 3. They are said to be the vertices of a quadrilateral ABCD. Banega na? There are 4 points, so we can make a quadrilateral. We have to prove that it's a parallelogram, or we can also find out whether it is a parallelogram or not. The test that we will uses opposite sides of a parallelogram are parallel. If the opposite sides of a quadrilateral are parallel, then it is a parallelogram. So what we are going to do, we are going to find the slope between AB, slopes of AB, BC, CD, DA, the 4 sides. When we find the slopes, we will see that 2 sides have same slope and 2 other sides have the same slope. That means pairs of sides are parallel to each other. Opposite sides are parallel to each other. It's a parallelogram. Look at the solution on page number 121. Ask me if you have any doubt. You're reading the solution. questions. Read the questions carefully. It says, we have to prove that quadrilateral ABCD is a parallelogram. So think about a random quadrilateral. A, B, C, D. Now this will be a parallelogram only when AB is parallel to CD and DA is parallel to BC. So the names, the order of the vertices is important. Don't lose sight of that. Here it is happening. AB, slope of AB is 1 by 2, slope of CD is 1 by 2. AB, CD, they are parallel. Similarly, slope of BC and slope of DA, they are also same. That means, yes, quadrilateral ABCD is a parallelogram. If in the question, यहाँ पे लिखा होता BACD, then the answer would have been no, it is not a parallelogram. The order of the vertices matter. Order of the vertices tell us which sides are opposite sides. That is important information. Be careful. There is a very similar question in the exercise practice set 5.3, which is question number 5. You have to show that A, B, C, D are vertices of a parallelogram. So once again, we will have to find the slope of AB, find the slope of BC, find the slope of CD, and we will see that two of the slopes will be same, two of the slopes will be different. Be very careful when you write the answer. You can just limit your answer to yes, it is a they are vertices of a parallelogram. But अगर उतना लिखने से आप आगे जाते हैं and you are writing the name of the parallelogram also, then be careful that you write the name correctly, because order of the vertices will matter. Now, it is not necessary that the name of the parallelogram will be ABCD. It can also be BCAD. So be careful about that. There is just one other type of question which is required for this exercise, required for this chapter. So we have looked at coordinate, we have looked at geometry, we have looked at trigonometry today, we have looked at some algebra also, right? So there are some more questions which require more algebra. But question number 4 of practice set 5.3 is not one of them. Question number 4 is very clear. 3 points are given, A, B, C. It says are vertices of a triangle. Okay. Then find the slope of each side. So we have to find the slope of AB, we have to find the slope of BC, and we have to find the slope of CA. Very simple. M equals to y2 minus y1 by x2 minus x1. No trick here. Things become a little trickier when we introduce algebra in it. Example number 3 on page number 120. It says if the slope of the line joining points P and Q. Now the coordinates of P are k, 0. See, this is the algebra. Instead of giving a number, a variable is given. K, 0 and Q equals to, Q is coordinates of Q are -3, -2. Slope is given. Then find K. Very simple method to solve this. We will say M equals to y2 minus y1 by x2 minus x1. In this case, this is our x1, y1, x2, y2, and this is our M. We will just put those values here. M equals to 2 by 7. Y2 is -2. Y1 is 0. X2 is -3. X1 is K. From here, all we have to do is use algebra to solve for the value of K. That is what is given in the textbook. Read the solution. Ask me if you have a doubt. Question number 6 of practice set 5.3. So here also we have 2 points R and S. R is 1, -1. S is -2, K. And the slope of the line is given as -2. Using the same logic, we can find the value of k. If I try to write it for you quickly on the screen, it will be something like -2 equals to k minus minus 1 by -2 minus 1. Very simple. There is one more question like this in the practice set. Now it says there are 2 points B and C. Slope of the line is 7. It is given. B is k comma minus 5 and C is 1 comma 2. So once again 7 equals to 2 minus minus 5 by 1 minus k. Then we solve this, we will find the value of k. Algebra. Finally, in the last question of the exercise, we have parallel lines. So it says PQ is parallel to RS. PQ is parallel to RS. And we are given with P, Q, R, and S. Their coordinates are given. We have to find K. Oh, yes, there is a K. We know that when the lines are parallel, their slopes are same. That means PQ का slope और RS का slope same होगा. PQ का slope कैसे निकलेगा? 6 minus 4 by 3 minus 2. X2 y2 minus y1 by x2 minus x1. RS का slope कैसे निकलेगा? K minus 1 by 5 minus 3 equal. Once again, linear equation in one variable. Solve to find the value of K. That is it in slope of line. So with this, I sincerely believe that we have completed distance formula, section formula, and slope of line. We have completed all the theory that we need for this chapter. You will complete this as homework. You will complete your notes, especially the formulae, different formulae for slope. You will solve the examples, questions that are there in the examples, and you will also solve the questions that are given in practice set 5.3. Complete and submit by tomorrow night.